We're at the Lake Blackshear Marina and Resort at the Veterans Memorial Park in Georgia. Two things that we have to do about marina operations and underground storage tanks are regulatory requirements for environmental issues as well as fire code issues. The environmental issues, especially dealing with the marina operation, is not only do we have to make sure that the underground storage tanks meet regulatory requirements and do not leak, but we also have specific items to deal with on the marina as well as the dispensers and docks so they don't leak into the lake. One of the things I want to start with is the tank pad layout itself. When you have an underground storage tank design, you have a concrete pad that's over the tank pit itself. The first item that I want to point out is a monitoring well. Monitoring wells will be circular, covered with a black triangle. Those monitoring wells are designed so you can actually open up and look at the water table in and around the tank pit to look for sheen or product that might be floating on the top of the surface, and also to take samples of the water table in case you have a problem with your tank pit or a possible leak. The layout of the system starts with the interstitial monitoring and the fill ports. The interstitial monitor is a bright sensor that's always on. That again monitors the interior of the inner and outer wall with a brine solution. The brine solution will float up and down with pressure, and if it leaks into the tank or out of the tank, that brine solution changes, either up or down again. We have a fill port. There are some specific regulatory requirements about your fill port, and I'll go over those when I open this up and show you. This is a secondary port that gives you access to the tank in case of emergencies or if we have to pump out fuel in a repair or something that happens in that respect. This is the tank pit or the tank sump itself. You'll notice that there's pea gravel in and around the tank pit. That's to allow water to drain away from the tank pit and not store on the top. Fiberglass lid on our sump. There's an O-ring in and around the edge of the sump lid itself. That makes a seal so when water comes across, it doesn't flow into the pit or into the sump and contain into the sump. This particular system, again, is a double wall fiberglass tank. It's a pressurized system. The pressurized systems mean that you have a pump on the outside of the tank that pushes fuel to your dock. There is a monitor here, a part of our automatic tank gauge system, that monitors the levels of the fuel in the tank. And then you'll notice that there's a sump sensor in this location.
Why is that important?
This sump sensor monitors any liquids or fluids that would be in this sump. Generally, you'll get water, which is not an issue, but that's there in case you get a fuel leak. If these lines leak and fuel comes back in here, it contains about 175 gallons worth of fluid, and that is right at the very bottom, so any moisture or any fluid that starts to build up in this sump gives you an alarm on your electronic monitor. So then we have to come and check to see if in fact there is a leak going on. Part of the pressurized system, one of the things I want to make sure you understand the difference, this item right here is an automatic line leak detector. This is part of all pressurized systems. It's a requirement that this be tested annually to make sure it functions. If you lose pressure in your fuel line between here and the dock, this system will shut off and not allow any flow of fuel to come forward from this tank. That's also a fire code issue. If it loses pressure or a line breaks, it won't pump 10,000 gallons of fuel into the lake. We have some double systems on our tanks. It's not everything is required, but we wanted to be safe and make sure that we over-design and had that, because the biggest issue is if you don't monitor and understand that you have a leak, you'll pay a lot more in cleanup if you do have a leak than you would in designing or over-designing the systems. One thing to remember, especially when you're dealing with gasoline, diesel fuel, or any fuel systems, is all of the electronic componentry have to be in intrinsically safe components. In other words, explosion proof, so no sparks can occur in case there are any vapor buildup inside the sump level. All of our conduits and all of our electric components are intrinsically safe or explosion proof. But I wanted to point out the flex pipe that comes and holds the fuel or pushes the fuel to the marina dock goes through a secondary boot and is contained in a containment line. Not only is the fiberglass double wall piping there, It's in a containment line as well. And this is the interstitial sensor where we monitor the brine solution between the inner and the outer walls of the double wall tank. This is a bright sensor. That means it's always on, and it's monitoring a level of solution. Again, between the inner and the outer wall, the solution is brine. And in this particular case, we're using an interstitial monitoring system made by Intelligent Control. There's a float inside of this system that has a 2.5 to 3 inch window that this solution can monitor up or down in that. It's built-in reservoir on top of the tank with a PVC pipe that floats inside of this. If you get less brine solution than is required, it will go into a low brine alarm, which means that you might have a puncture in the outer wall of the tank or an inner wall of the tank. The brine solution is less dense and will float, so you'll get more fluid or liquid inside of your tank very visibly. If you lose it to the outside, it just leaks out into the ground, and then we can come and check. If you get more or a high brine solution, that means you possibly have a puncture to the interior wall of the tank, which means diesel fuel or gasoline is going into that space between the inner and the outer wall and making that float rise. So we monitor this pretty much all the time. It can be affected by pressure changes of temperature, hot and cold. That is most likely the case. Very seldom will you actually get a leak that will require us to look at a high or low brine. More than likely, it's going to be monitoring the pressure changes from the outside of the tank pit. But that's the first issue and the first case where we have the new secondary containment statewide. The way that this helps you maintain compliance is the alarms. This is always on. It's electronically attached to our tank gauge on the inside of the facility. This will also tell you monthly whether or not the sensors are working. Not only the sensors in the sump, but the sensors here show you once a month that they are in fact working. The best way to do this to make sure you're in compliance is to come out, make it go into a low or a high brine alarm at least once a month. That way you know it's functioning the way it's designed. Now what we're going to do is look at the fill port. This is where your delivery driver will drop fuel. You'll have a cap on here. Also has the facility to be padlocked. Sometimes it's required to be padlocked. Some organizations would prefer it to be padlocked so that you can be present when the tank truck brings fuel to your facility. Part of this issue that we have with secondary containment and overfill prevention, we also have spill prevention. There is a fiberglass spill bucket that's a part of the fill port itself. It holds 15 gallons of fluid. That allows the delivery driver, if he delivers and undoes his clamp and spills or splashes fuel, it's contained in this spill bucket. That doesn't get any fuel into the dirt in and around or into the tank pad itself. This particular design is when this door is shut, any fuel that may have been splashed during delivery, this forces the valve open and that fuel then will go into your tank. All of your fill ports should have a cap on here. This is specifically designed again to control vapors and moisture. There's a brass fill ring adapter that the delivery truck must clamp to with a specialized nozzle so they can do gravity drops. Double wall fiberglass tanks should not be pressure filled. They should only be gravity fed. That would interfere with the integrity of the tank if they try to do a pressurized fill. Inside, there's a drop tube, this aluminum tube that goes down inside of your tank. That drop tube also has an over limiter valve or limiter valve that does not allow any more than 95% of the capacity of this tank to be put in here by a jobber. That actually will float up and shut off the flow of fuel, and they won't put any more fuel in here. This is definitely a regulatory issue. You must have a brass cap like this with the drop tube with your auto limiting valve inside. One of the issues with the auto limiter And the way this is designed not to allow more than 95% of the tank's capacity to be put into the tank is that this will alarm on our automatic tank gauge system inside. So the owners and operators will always be aware if there's too much fuel in their tank. Sometimes when you have a different setup, there is an audible alarm that's outside that the jobber knows that they're getting close. In this case, there is no audible alarm, but this tank will actually stop allowing fuel to be put into it because of the auto limiter valve. And again, part of what I was explaining about not having pressure drops is that double wall fiberglass tanks are designed specifically to allow a certain amount of fuel to be into the tank or delivered into the tank by a jobber via gravity fill. Specifically, there is a requirement to have a vent system that allows the pressure or the air to dispense out of the top of the tank. It should be 12 feet above the ground, and there's a cap on top of that that's pressurized. That's why it allows exactly the amount of air into or out of the tank required in a double wall fiberglass tank. If a jobber tries to pressure fill, this valve will not operate correctly, and more than likely, in most cases, you'll see fuel be pushed or forced out of this vent, and you'll have a spill based on him trying to force fuel into the tank.